Now. Okay, so what I'm doing here, I'm taking a very simple step here, simple program, a very simple program, and in this, what we are doing here is we are just logging into the system or logging into the program. Even you can do it in the display mode as well, and you can type /h here, okay, /h here, and then debugging is switched on. This is one way, and another way is directly you can do it from here as well, like from the main screen itself. You can just type /h here. Okay, let's say we type /h here and then say enter, and the debugging switches on from here itself. So which is like, from the easy access screen only. So SE38, I'll just log in SE38. So even this also we can debug. Let me exit this. Now here in the beginning screen, the initial screen itself, I'm typing /h here, and the debugging is switched on. So it will start, the debugging will start from the beginning. Okay, so there's no other change, like we'll start from the beginning. And now when we have /h, what happens is a lot of standard program also will come into existence. We have to go through a lot of standard program as well. So that's the drawback of /h. But you can start looking at the program from the start. Okay, so what exactly triggers? What triggers when we execute a program, any program? What triggers is the process after input. This process which we are seeing right now is common for all. It's common for all the programs. Whatever programs you execute from SE38 or from the ABAP editor, this process will be same. So we need to have, we will be getting this process after input, and then we'll have chain, then we have module exit. So after this, like when you execute this, it has this FC code. These are all the SAP standard program, and I'll execute another program also. The process will be, the steps which we are seeing right now will be same, common. And we are looking at this in the latest version of S/4HANA 1809. So this is the standard program where we have this set parameter ID, RID, and all. Now in this, if you observe here, the number of lines of code, and you can see on the top, you can see the program name which gets executed. Remember that the standard program always moves from one program to another program. It changes, like the program name changes. So it calls another program, it calls another include program, it calls another form. So there are many things that will be called from the program. So all these things will be displayed on the top. You can see the details here, and you can see the size abarc value. What exactly is the size abarc value of this? And you can see what is the function. The function is like rs underscore program name underscore split. Okay, and now when I execute this, when I click on F5, it changes. The values change here. Like, the line number has changed. The line number has changed to 236 now here on the top. You can see here on the top, and then we have this LSEQ U01. This is the value that this is the I'll show you this one. This is a function actually. So this function also I'll show you. Now when we have rs underscore check underscore rs underscore character underscore check, this is the one which we have a function. So the function also changes now. Now we have rs underscore program underscore check name. Now here we have LWBA ABAP I000. So we have check directory. Now here you can see SY tabix. Okay, tab index. SY tabix is tab index. So you can also check the tab index. Okay, SY tabix value is here. You can see the program name here, and you can see the function name here, the field name. And now you can see that there is a form getting executed. So here, what is the type of the object that we are into? Okay, what is the type of function that we are debugging? It's a form, means subroutine. It's a subroutine. So we went into the subroutine. From the main program we went into a subroutine. And what is the subroutine name? Info system underscore object underscore program underscore get. Atish, are you following?
Yes.
Sandeep, are you there?
Yes, sir.
Okay. So here we need to observe the program name. We need to observe the line number and size abarsi. What the size abarsi will give you? Size abarsi will give you the line status. For example, if you have given a select statement, and for that select statement, whether it is successful or not successful will be defined by the size abarsi value. If size abarsi value is 0, means that line which has been just now executed is successful. If it's not 0, then anything other than 0, 1 to 8, any value, it will not be, it means that it's not successful. So we have seen, in the coming lines we can see size abarsi changes. Now here if you see, in this the line number is 1608. We are executing a form called is underscore expandable underscore object. Now let's look into the different tabs that we have here. We have the desktop one. In the desktop one, this is more of similar to classical debugger. It's more of similar to classical debugger. What the classical debugger used to be look like is, it would look like something similar to what you can see on the screen. Here we have the variables, variable 1, variable 2, local, global, auto, memory analysis. So many options weren't there in the previous classical debugger, but these are all the options in which we can maintain the variables. For example, if I click on this variable, the variable comes here, and you can check the value here. The value isn't there. When I execute this line, the value is updated here, name. Now if I double click on this key field 2, it doesn't have any value because it's not yet executed. This line is not yet executed. So when I execute this line, automatically that value will be filled up in that. Okay, it didn't fill because there's no value at all. And now we have variable 2. In the variable 2 also we can assign some, we can enter some values. We can keep these values just like that. Okay, we can keep them on hold, and then we can go to the variable 2 and we can also check that value. So for example, there is a set of fields that you want to do it in one variable 1, and there's another set of fields which you want to check in a variable 2. You can do that. You can also type internal table name and you can just check that value. So desktop 2 happens to be a screen in which we'll have ABAP and screen stack. See, in the desktop 2, whenever you are executing the program, you will see the event type, you will see the event, and you will also see the include program which has been executed. Now if you see, if I change the line, automatically this cursor which you can see on this 19 will move on, will change now. Okay, so the stack level will change. We are still in the form, so it's not moving. Now it's changed because we have moved out of the form. You can see now on the top, you can see the function name, and you can also see the top function here. And this include program name, which you see here, the include program that gets executed here on the top, can also be seen here on the right side. Okay, so I'll just move it here. So now we are getting into the perform statement, and now the perform statement will be updated. Now here it was rs underscore update underscore f4 underscore value, which is actually a function. Okay, but now we are getting into the form. So, how do we get into the form? Whenever perform gets, whenever we get to the line of a perform, automatically it will go to the form. So I'll just click this, and now it has gone into the form. The form name is update underscore EU F4 values, which we have seen now, and you can see on the right side the event that got triggered, event type, that's actually the object that we have here, and the event name, that is update underscore EU F4 values, which you can see on the top as well, and the program name you can see on the top as well, and the include program which has been triggered. And the line number you can see here, and this line number you can also see here. Yeah, here this is the line number which you are seeing on the top. This is all related to desktop 2. Desktop 1, why we go for desktop 1? When we want to check the values of variables. And remember, if you have the variable values, you can also change the variable values in runtime. Because this is a standard program, I'm not changing it. But if it's our own program, I'll make changes to the variables and then show you. If let's say a is equals to 10 and now you updated in the runtime a is equals to 20, then automatically that gets updated in the program. And when you see the output shows you that 20 value, not the 10 value, because you updated that in the runtime. And that will be only through the runtime. After second time when you execute it, you come out of it and execute it, automatically by default the 10 value will come. So we all already know that. And then we have the locals. If you have the local variables, okay, the local variables that we have here, if you have defined any variables, then that local variables will be shown here. Now since we are executing a program which is ZJ software underscore inline and inline 1, that's a program name. The program name is coming as hide object. Globals, you can see what are the global variable names that we have been using here. So the list of all the global variables that we have here, and you have auto. Any value, any variable name that gets created automatically by default will be shown here. Now, if you want to see the memory analysis, for example, if you have an internal table which is taking too long time to execute, then you have to go to the memory analysis, and in the memory analysis we have to give the value name, table name, and then you can execute it and see how much time is it taking. So you can just go for simple variables, it doesn't show you difference, but for our understanding we'll take one. So you can see that how much memory, okay, memory is used is almost 0. So it's like used object memory 80. So allocated object memory 80. So this is what we can see, the memory analysis. Memory analysis becomes extremely important during the performance analysis. For example, if a program is taking too long for execution, you need to go and check the memory analysis. This is where you have to come down when we are going into the performance analysis. You okay with that? Errors, anyways, we are going to get directly to the error, but here when we are checking the performance, you need to come through the big performance analysis here. Now here we have the desktop 2, okay, desktop 3, we have the variables on the right, and here whatever you can see on the desktop 1, what you can see, this is similar to the classical debugger, but the same things you can see on the right side when you go to the debugger desktop 3. On the right side you can see, but here you can see other options as well. Delete and all additional options are there, but otherwise all the options that we have in the desktop 1 will be there here in this. Okay. Addition to this, we have the options on the top. This is a standard one wherein you can see the desktop 2, whatever you are able to see, all this stack and all. Okay, this one and the desktop 1. The desktop 1 what you are seeing and desktop 2 what you are seeing, the entire thing will be displayed in standard. In standard we have the event type, we have the variables, everything. So this is a part of the desktop 1, 2 that we have seen, and this down one is a part of desktop 1 and 2. So in the standard you will be able to see all these two. Both the things will be displayed here. Now if you are probably focusing completely on the variable values, you can go here, and memory analysis anyways is there. So what is standard? Standard is a combination of desktop 1, 2 and 3 you can say. And structures, if you have some such structures, if there is a structure that gets executed, or if there is a structure which is already existing in this program, you can just type the name of the program structure and you can see what are the values that gets populated in this structure. Then we have the tables. In the program, whatever tables that we have that come across in this table, in this entire program, can be typed here, and that value, I mean the values which are there in that internal table will all get populated here. So we can write write a small program in which we also have an internal table, and that internal table values we can see here. Then we have this object and object view, details, data explorer, breakpoint, watch points. Now here if at all, if you have set any breakpoints, if at all, if you have set any watch points, those things you can check here. For example, let's say you have created one watch point and you have created two breakpoints. All this will be visible here. And this is where we actually see the comparison of variables. So what is the value of it and what exactly, if for example you have A and B, so you want to check the values of A and B and you want to compare, so you can do that in the difference. Then this is a script. Script is like the program. If you want to see the program here, only the program and start the script, you can start the script as well here. So related to this objects, detail, data explorer, and difference and script, we are going to cover in the next session. But now I want to complete the standard structures, tables, objects. So these all things will be covered till say tables. Till tables will complete it, and then we have the breakpoint watch points as well. So breakpoint watch points, anyways, we have to do it now because the complete debugging we are doing it now with /h. But after that, we have to do the debugging with the breakpoint. So setting a breakpoint also we'll do it now once we understand this process. Okay, I've just come down out of the program. So let me set a breakpoint in this program. So, and remember, you have to, if
Hello?
Yeah.
Can you execute? Can you do debugging through transactions?
Yes.
XD01.
Yeah. Okay. Let us first check that. Tell me a transaction code.
XD01.
HD.
XD01.
XD01. Okay, for a customer. Okay. Okay, so here what we'll do is like in XD01 you are supposed to enter the data, and then debug. So what I'll do is, for our understanding, I'll go for XD02. XD02 is for change. So we can take one existing customer and then do it. Instead of change, you can also go for XD03. So I'll take an existing program and then existing customer. Okay, the sales org. Okay, sales org, I'm not giving it right now. Yes. Now you will get this. So you need to make sure, if at all if you are doing it, you need to make sure that when we are logged into any transaction code, first give these values, because without giving these values, if you go for debugging, it will unnecessarily take you to standard code. I mean the code which is actually not required for you to debug. There's not. First you need to enter the customer value. If at all, if I'm telling about XD02 or 03, but in 01 you have to start even before you give the value. So I just say enter. Now I have come here. Now I can type /h here. I'll type /h here. So when I type /h, from here whatever we execute will be under the debugging concept. So whatever we execute from here will be debugging. So now if I say enter, automatically now it directly takes us to the debugging screen, wherein like what exactly is the program. So the program which is behind this XD03 is SAP BUS underscore locator. So that's a program which is actually running right now. Okay, and it might change down the line. Okay, now here a class is getting executed here. Now, if you let's say you want to see the value of EV underscore OK underscore code, okay, you want to just check what is the value of it. You don't have any value here. Okay, you don't have any value. So you can also in live, I don't want to change it now, but if you click on this and you enter some value here, that gets updated with that value, EV underscore OK underscore code, wherever it comes down, that latest value gets updated there. Now in this, when we are doing this debugging, what we can do is we can also set breakpoints during the in the program. So how do you set a breakpoint? Because let's say you have a specific issue. Okay. Can you tell me a specific issue what you are facing in XD01? Hello, Atish, are you there?
If I want to put additional value there, whatever we right now exist, we have to put just additional value. Just show me that.
Yeah, okay. So additional value for the existing field, right? So for
Right.
additional value for any existing field, how do you do that is as of okay, this value is gone, right? Okay, let me see one variable. When variable comes, I'll update that.
And how to find that proper function model
Which function module?
that is there in the that field. If suppose one field I have to update, and how to find that function model for that field, and how to debug that.
Okay, let's take again XD
Go to
0.
XD03, put the customer there, click on customer sales area. Just go back.
You want me to enter customer sales area by default will be taken here. Whatever customer
No,
sales
no, no.
area.
It will not take. Click on customer sales area. That
I'm
that
sorry.
that that tab is there, na? Customers sales areas.
Okay.
Click on that. Hmm.
Okay. Yeah, you want to check what field? Tell me the specific field here.
Mm, if I want to check the planning group,
Okay, planning group. You want to check the value for planning group
mm,
in the runtime in the debugging, right? So what you need to do is first we need to find out the name of technical name of that field. Technical
okay,
name of the field. So technical name of the field, how do we do that? We just click on F1 here, select this field and click on F1. Okay.
okay,
Now here in the F1, you'll get the technical name, technical field, technical information. Click on the technical information and you will first know the field name. Make sure you write down the table name and field name somewhere. Okay. So table name
KNB1.
and
Just a minute.
yeah, FDGRB. KNB1 is the table. KNB1 is the table and field name is FDGRB.
Okay,
KNB1 is the table and FDGRB is the field name. Now this field actually this field name is actually we need to copy this. Let me copy this field in the program. Okay, let me go to the program. System, status, and this is a program name. Okay, so SAP LBUS locator is a program which is actually running behind the XD03. Remember, for every screen obviously there is a program, you already know that, right? So this program name is what you need to just copy it, just copy the program name, and then you need to go and open that program. You can also double click on this, in fact. You don't have to go to another screen. Okay, let me copy the field name. Can you tell me the field name?
FDGRV.
Okay, I'll just then if you already remember that, I'll go into this directly. We'll go into this, and I remember that the table name is KNB1, KNB1 for sure, and then hyphen. And what's the field name?
FDGRV.
FTGRP
V. V
V.
for Victor. Yes.
FTGRV, right? Okay, let me first check for that value. Is it there? Okay, it doesn't look it's there. Okay, so what I'll do is FDGRV is what I'll look at FDGRV. I'll only look at every GRV. The master program. So in the FTGRV, actually, like it. Okay. Okay, B1. So they have used some other values. So let me look in this top. Okay. Now in the speed group. Okay. Let me debug that and select this value. Planning group, right? Okay. So let me come from this other way. XD02. I'll go to XD02 and in the XD02, I would like to change that value to 03. Okay. Once again. XD02 and this is 203 and I need to click on the customer sales area, right? So I'll go for this customer sales area and I'll select the planning group. Before selecting the planning group, what I'll do is I'll type /h here. On the top, I'll switch on the debugging mode /h. Now whatever I enter, it will directly take us to the debugging mode. So I'll just type, okay, which planning group you want me to give now? Oh, it goes to the help. Okay, I'll cancel this. XD02 203. Okay, planning group. Let me first take a planning group. I'll select one planning group from this. I'll select domestic payments A1. Okay, and now I'll type this /h, say enter, and now here I'll select A1 and enter. Now it will directly take us to that particular field. So here, this is getting triggered here. This time pro PI underscore begin is getting triggered. So in this, let me get into this. This is a program name.
Call method is a function, right?
What happened? I'm sorry.
Call method means it is calling to function, right?
Yes, call method means it calls a function module.
And that call function means
Call method, okay, call function will be a function module. Call method would be from a class. A method is a part of a class. So it actually is calling a class.
and that function model can be a part of class.
Function model can be a part of a class. No, we don't and we don't enter a function model within the class. No,
Okay.
it can't be like that. Okay, so I'll just say enter. Uh, okay, I'll go for /h, enter. I'll go for save. Now it comes here. Whatever you can see call method, whenever you see call method, it's a part of a class actually. So we're calling a class. So we have screen values, screen fields. So we have the screen fields. This is where we have read screen fields, gt underscore screens. We already have screens. Okay, let me see the fields here. These are the field names. Okay, we can see the field names. Columns. We have in this particular table we have three columns. One is program underscore name, dynamo underscore number, and screen. These are three things that we have here. Program name and field. Okay. So certain fields dynamically gets populated. When we say call method lv underscore screen, this is a part of this. Lv underscore screen is a class name, and pa underscore begin is the method name. So if you take this here lv underscore screen, you can go and check in SE24. Let us check that in SE24. lv underscore
That
screen.
that will be the object, right? LV underscore screen.
Sorry.
Right, right, object.
So actually, it is taking a reference. Actually, LV underscore screen is an object that is getting the properties from some another class. Okay, so this is a method. This is actually an object. Object is an instance of a class. So if you are directly calling from the class, it's a static method. Here double line will be there. If it is double line, it's a static method. This will be the class name. But LV underscore screen is taking the properties from a standard class, and this is lv underscore screen is an object actually. So this is a class here. Type ref to cl underscore bus underscore abstract screen. So this is the class name, and we can go and check that class name here. So this is a class which is being executed there. The field names, and so what is happening here is the field names are getting populated dynamically. Now we need to check out into which field name, in that particular screen, which field name this data is getting on going and sitting. So we have Dynpro number, screen number, and all these things, but we will not have this field name. We don't have it here. So I repeat what I said. Basically, everywhere wherever we have this, a class is something where we have certain a set of lines of code. So a class, okay, and class cannot be directly used in the program. If it is used, normally we don't use it, but if you use, then you have to call it from the directly from the static. We call the field statically. So now class, where do we define the class? In SC24. In the normal program also, but for when we talk about the standard programs, all the classes will be defined in SC24 transaction. Now in the program you define objects. And how do we define object? With type refer to type reference to class. So for example, if I say class name is cl underscore jsoftech, then this is a standard class, and So here we have this class CL underscore JSON. So this is if this is CL underscore JSON, it is a standard class. If you have Z, then it will be obviously a customized class. And remember, there is no need of writing CL underscore always. We just normally write it for our indication to understand that it is a class. And then this is where is been defined SC24. Object. Okay, how do we create an object in the program? We write data obj1 type ref to zcl underscore jsoftec. Okay, so obj1 type ref to zcl underscore object. Now what we do is we use this object within the program. We don't use the standard class. I mean, like the standard, the global class. The global class properties all will be copied to the object, and in down the line in the program, if you want to call a method is a part of a class. So how do we call a method? We say method call method obj1 zcl obj1 and the method name. Let's say m1 is a method. It's already been defined. It needs to be defined in this zcl underscore js object. Now what is m1? M1 is a method name which is already existing in the standard class. And what is obj1? Obj1 is the object which we are taking as a reference. So we are looking out for a line. We were actually looking at a line in the code wherein we were actually checking out the object name. Now what did I do? I went and saw what is from where it is being called. Now let's say you want to call static methods. So the way we call a static method is like this: call method obj, no obj1. If it's a static one, then we'll go for zcl underscore json, directly the class name. And if we are giving directly class name and m1, this is how you call. So how do you know whether this zcl underscore json is a class or an object is? If you have double line here, then it means that the left side one is a class, and if it is a single line, it is an object. So object. So we have, when we see object, we need to go to the reference class and then go and check in that class what do we have. Okay, so now as I told you, you cannot introduce a function module here. So okay, within the part of a method. Okay, so let us come to this way. If you have this method, inside the method you can call you can write a function module, it will call. But here in the variables and all, we will not be able to define. I'll tell you what is possible, what is not possible. I'll tell you on that when it comes to the function model. I'll give you an example for that. So let me come to the conclusion of what we are discussing. We were discussing about the field name. So how do we check the field name? Is we need to go ahead and select this field name. So this is lb underscore cursor, doesn't have any value here. Okay, just skip that. Okay, so here we have gt underscore screen size standard table. In this, like, we'll be finding out the field names columns. Okay, program name. See, the field names automatically dynamically get generated. So I will explain you the exact field name. That field name which we have taken an example. So we'll come to that field I'll catch that field and explain you, because I just need to work on this and see into which field name it's getting populated. Okay, you understand that? So let's say now I have seen, okay, let me give you an example of the same thing. Now what happens here is certain variable names are dynamically generated. Now here if you see somewhere down the line in some include program, let's take an example of this obj1 only. Now this what happens to obj1 we have declared zcl underscore jn softec. Okay, and this is we are taking the reference of the standard class into the obj1. Now if you check the program, you will never see anywhere this class name. Only in the declaration somewhere one place, at only at one place that zcl underscore jn softec will be there. In the entire program only obj1 will be used. Similarly, the field name that we are actually searching for, okay, the field name which we are searching for the xd02, that example, actually might be passing the values from that field to another field actually. So that is what I need to check, and from which field to which field it is coming. I'll explain you. So I need to catch hold of the screen. So how do we do that is, I need to catch hold of the screen. Okay, so what I do is like, you go for status, and in the status you can see that its dying pro values, the screen number is 3000. Okay, so in the program SAP LBus locator, I need to check the logic in the dying pro number 3000. What is the dying pro number 3000? That's a screen number. Actually, for every screen there will be a screen number, so that screen number will be visible here. That's coming around to 3000. Now here we need to go and check that. Okay, let me come to this again. Okay. KNBM 50 GRB. Yeah, this is the dyne pro field. GS underscore KNB1 FDGRB. This is a dyne pro field. And program name is SAP's LBus locator. Okay. ABS no, okay, so I've just let us try with that value which is already there. Okay, so I just need to type in all the fields, all the. Okay, so what happens is here is like it is actually getting a logic in the screen. So I just need to, okay, let me go to the screen number 3000. Let us check that there as well. SE51. So we go to the SE51. Let us go to the SE51 and do that. Okay, sorry. need to type the program name there. This is a program name. And the screen number was 3000. In this, there might be a logic here. Again, we have modules here. So these modules data logic will be written in maybe some other, maybe in some other include program. We'll just check this. So we have given some input, process after input. Okay, so in the process after input only, we'll have this PA and PA begin call subscreen PA end. It should be there. Again in this, okay, this is there in the LBus locator 01 include program. We just need to get into this one, and here we have this SYREP. This is a program name, then to end, then program name, and then pro number. Here, okay, good. So we don't have much of logic here. Then pro begin. Call method cl underscore bus. See, this is a static method which you are calling from the directly from the class. So when you click on this, it will directly take us to that class cl underscore bus underscore abstract underscore screen. Wherein the program name and the DynPro number is being displayed. We need to display we need to get into the field actually that field where it's getting populated. I'll just check that and explain you. So we need to get to that field name actually, from which variable to which variable that field value is passing is what we need to check.